We're about to do random access files. So here I'm recording it. This is 12.9 of our file I/O. A random access file is different from sequential access. So far we've seen writes and reads, and we've seen the get lines and the other stuff we can do with streams. We can write and read as binary. We can insert as a stream. But that's all sequential access. You write to the same location and then the next location and then the next location. So your writes just march through the file, one line at another, and it starts at the front and ends at the back. Same with reading, right? You start at the front of the file, read one line at a time, and get to the back file. In order to get to the back file, you have to read through the front of the file first. That's sequential access. It's slow. The other way is random access. Random access jumps right there, very much like an array. With an array, you use an index to jump somewhere. And that's what these random access files do. These random access files are going to use two functions. One's called seekg for seekget and seekp for seekput. This will set a reader or a writer. Seekget is the reader, a seekput is the writer. Where are you going to read or write to a certain location? How are they used? Here we see examples of use. We have some data file. Here we have in data. It's probably an in file. And we do seekg for seekget, removing the where are we going to read from this in file to 25 bytes from the beginning. So it's the beginning plus 25 bytes. That'll be the 26th byte. The beginning would be the 0th byte. So we're adding to the beginning byte location, or the beginning address, the front of the file, 25 bytes. We're jumping 25 bytes down and starting reading from the 26th bit. Similarly, we have the seek. We can put negative offsets. That's what this 25 or this minus 10 are, is an offset. And it says go from the current position and go back toward the front of the file 10 bytes. And that is where we're going to start writing to. So we're going to move our writing position 10 bytes back in front of the file, toward the front of the file, and start writing there. Do note that when you write, it's going to overwrite what's in the file at that 10 byte position, 10 byte earlier position. If end of file is true, it won't let you move things. So we need to clear the end of file bit before we can do the seeks. So here we have this grade file. I suppose it's a list of grades in binary. And we do clear to unset that end of file bit and all the bad bits. Now I can move around. We do seek G, and that will seek the set the G is get, set the reading position to 0 bytes from the beginning. That's at the beginning of the file. So that is one way to reset a file without closing it. Tell G is going to return a lon int or an address from somewhere. Returns the current position, byte position of the input file is probably from the very beginning. So where am I is probably how far you are from the beginning. Notice it's a lon int. So these offsets are lon ints, which is the type of integer. It's a big integer. We can see that the literals we used for these offsets are also lon ints. 25L, not 25, 25L. So it's still 25 bytes, but it's in a lon bit. So we're not using much. We can do huge bits then with lons, huge offsets. Opening a file for both input or output. So they don't really give any examples of that seek. It's there for your convenience. I don't know if I've used one somewhere. Again, I haven't used a file I/O in a long time, so I'm very rusty in it. Opening a file for both input and output. So here we have this file called grades.dat. We have in and out. So we're opening for both in and out. If we open it for in, it should exist already. And opening it for out should open for overwrite. So both the in start and the out start should start at the very beginning of the file. If we write to this file, we start overwriting the file. If we read from this file, we read from it. Can also use binary flags. So it looks like we can do this random access stuff, this in or out, to a text file, which to me doesn't make sense. Maybe it's not the random access. Maybe this is sequential access, but we can open it for both reading and writing at the same time, which doesn't make sense to me. Why would you do that? Here's something new in C++ 17. They added a file system. This I have never used, so I have no idea what it is or how it works. So the file system, I assume, will do the directory structure of your file system. All the file system functions and types are in the file system namespace, which is in the standard namespace. We have two namespaces here. Remember, we did using namespace standard. Inside that standard in the file system is a file system namespace. So it needs to be standard : file system in this file system. I think. Let's see if they have an example. In your file system, files are stored in folders. Directory is the same thing as a folder. C++ documentation, directory is typically used instead of folder. So in the documentation, you'll see directory. Here's an example file system. All file systems have a root, directory, and a drive number. So this looks like they're backslashes. So this looks like a DOS file system, or what is it called? FAT32 or FAT64, which is used for Windows machines. So it says here's an example of a Windows path name. C: is the drive. So you have different disk drives. Generally, each gets a letter. You can have partitions. Each would get their letter. And they all start the data at that part of the file system starts with the root directory. And that's the very first slash. So that first slash is a folder containing goodies in it. One of the goodies could be a folder. So here we have /users. And then users has another folder called Blake, and Blake has another folder called temp. And in Blake's temp is a finalexam.txt file. So we have folder, 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 and finally at the very end we have some kind of file. This tends to be the file structure used everywhere. I haven't seen a different type of file structure. They all tend to be this hierarchical file structure that has a root. So it's a tree structure. Here's a Unix style path. Notice that in Unix the slashes are other way around. And they don't list which drive it's on. Root, home, Blake, temp, final exam. There are different kinds of paths. We have absolute path and relative path. An absolute path starts from a drive. So here in the C: /root, we can get to sheepdog.jpg, but we get it all the way from C:. So we can use an absolute path anywhere, and it will retrieve a unique file from the very root of that drive. That's an absolute path. Here's a Unix example. And again, it gives where that file is and all the directories between the root and that file. Current working directory and the relative paths. Generally, when you move around a structure, there's something that's called a current working directory. Let's see if we can see that. This is console. And this is just output for a console. So let's do a change in the middle. And we'll see that working directory. So I'm going to add a comment here. Hi. When I add a comment, I can save it, and I build it, and we watch the build. We have incremental build finished. This is happening in the console, and this is happening in a drive somewhere. So I don't see it here. Do we have terminal here? We don't have terminal. Can I open a terminal? New window, editor, appearance, show view, build targets, console, terminal. Here we go, terminal. So here's a terminal, and this terminal has nothing in it. I don't know why it's there. Enter does nothing. Generally, you'll see drive paths in a terminal. So generally, let me get a DOS terminal open. A CMD. There it is, command prompt. So here's a terminal system. If I double click on the terminal, we can see where the current directory is. Current directory is in users bmshick. So the prompt that it gives me here shows the current directory. I can do a dir to show the contents of the directory. I can do a cd ... to change the up directory now to users. I can do a dir show that, and there is my directory bmsh, which is where I was before, and I can keep going up cd ... and this is a current directory dir. And then if I go cd ... from the root, nothing happens, right? I stay at the root, so I can't go any further up than the root. I can go down. I was in users, I think. cd users, there it is. And then from here I was in bmshick, cd bmshick, and from here dir. A whole bunch of directories. So we have a documents directory, cd documents, tab to fill it in, dir. And then from here I have screencast-matic and other stuff like this. So I'm looking for my other things, which I don't see here. It must be a different user. Interesting. cd ... cd ... dir public, cd public, dir document, cd doc, dir No, that's not it either. Unity projects. So I'm trying to wander around my fire structure, try to find out where I'm at with these demos that I'm showing you. But I can't find it, so I'll have to look it out later. What I'd like you to take from this is there's something that's called the current working directory. And if I do a PWD, I don't know if that works, oh, it doesn't work. So on Unix, PWD is print working directory. I think dir says show this directory. It says directory of and the current working directory. So that's the current working directory. It's where you currently have your commands going. And so it's a directory that the commands look at first. It's called the current working directory. And you can ask for other directories from that current working directory. It gets saved in a environmental variable. Program is running has a current working directory. When the program creates a file, the file will be created in the current working directory unless a path to some other location is given. We know the current working directory. We can use relative paths to specify locations on the disk, and a relative path specifies a file location relative to the current working directory. So we have relative directories or relative paths. So I can say run some file from my current directory. So this didn't work. cd dot dot cd dot dot ls, and I can do dir. I can do dir bm sure. And so instead of doing the dir where I'm at, I said do the dir or the show the directory in the bmshic directory. So I'm giving it a relative path from where I'm at. And in the bmshic directory, I have this documents directory or downloads or Dropbox, and I can go to the documents directory and look in there. So let's do that. dir bm schick backslash documents, and it shows the documents in there, Screencast-O-Matic and SQL Server, and so on. Exit. So that's the current working directory and relative paths. And so when you are creating paths to files, you want to know what kind of path you have. Is it an absolute path, which is always the same and always starts at C, and there are a lot of directories between the two? Or is it a relative path, which means come from the current directory and look around? So relative paths are useful if you're doing the same kind of thing in different directories. For example, in all my projects here, if we could open another project, I'm creating a source file called src. Maybe I want some program to run and collect all my CPP files and put them in some file. And to do that, I can go to all my projects and look in the source file in each project. So I can go to the root directory of all my projects, which I believe is demos, and then have demos go through every project, star in there, and in star look for source. And so we have some relative directory like star backslash source backslash star, and just copy whatever's there and put it somewhere. Star.h or star.cpp. That's what a relative directory is. Picture-wise. So I talked about current working directories. I talked about relative path. Working with path objects. This I've never done before. You can use the path data type to create objects that represent the path of a file or a directory. The following statement creates a path object named myPath. So here we have type, path object, or the path type. This is the name of the object, the myPath. Then the following statement assigns a string containing a path name to the object. States the image as sheepdog. It's like file name. Only instead of file name, we have a whole path. File system path myPath. Start here. Notice they gave this one a absolute path. C /users /Blake. Notice we have // in the double quotes. What does // do in double quotes? Anyone remember the string escape sequences? It's a slash be a slash. Otherwise, what is the slash? Special character, exactly. Like \n is the new line character. Both those two things. / and n together is a new line character. Suppose you want to put a / as a character in your string. Then we need to do \/. So this is a relative path. Wherever you see those two backslashes, there's really a single slash there. So it's the slash character. \/ is the / character. Right? Hopefully that doesn't make too much of an argument for you. Or using the raw string, if you put R in front, then it doesn't do any kind of escape sequences, which I've never used. I've never used that raw string. I have used the Windows example. You can initialize a path object. So remember we created a path object earlier. Here we go. Here we go. By using the path type and then naming the variable. But we haven't said, then we set it later, we set it to a value. We can do that all in one step by making a path object like we did before, and then using curly braces to set it to some value. So this is an initializer list, effectively. Set the value to, in this case, it's \images \sunset. So it is a absolute path. Down here we have a relative path. No, that's a Unix absolute path. We're almost done. You could. I don't know how to grab it. The environment variable will have the current working directory path. I don't know what other paths they have. They should have paths to the different file systems that you use, like where all the libraries are and so on. To display a path name, use a path object string method. So here we have myPath, which is the path object. String method will return the path you gave to it as a string. So far, it's acting just like a string, right? We haven't done anything with it. But we can do stuff with it. We have target path. We have this exists of paths. We have a function called exists. This is probably not a function. It's probably a macro or something. Exists, and you pass it that path. Remember, a path is a path object type. myPath was the name of it. And here we're calling exists on it to see if that path actually exists. Well, here's the example. We're creating this stats CSV file, which is in the data folder in the C directory, or in the C drive. And I want to know, does this file exist? Maybe I want to read from it. In order to read from it, it has to be there. So I'm going to check to see if it's there. I make a target path, say, I want this file at this location. Then I call exist to see, is that file there? And if this exists function returns true, then the file is there, or it returns false. It probably returns some number. That is 0 if it's false, would be my guess. So let's go find out. Now I'm curious. How does file system path work? C++, file system path. cppreference.com. Path object, root name, root directory. Path name is the following syntax. They're giving the syntaxes for the path names. Path can be normalized by following this algorithm. I have no idea what that means. Here's some member types, constructors, and I'm looking for this exists thing. Decomposition, empty, has is begin, end. It may be something that uses paths, not a path. So it's not a path itself, so I want the exists. File system exists. Here we go. Here it is. Checks if the given file status or path corresponds to existing file or directory. Parameters return value. It does give it true or false. Look at that. It returns a bool, not a number, not an int like we saw those is alphas do. This is an actual bool, true or false. Very nice. So exists returns a true or false, and we can then use that true or false in an if statement to change our behavior, or the code's behavior. We have another function called copy file, and it takes two paths, a from path, which should end in a file, and a to path, which should also end in a file, I believe. So the file specified by from path must exist. The file specified by to path must not exist, otherwise an exception will occur. So it's going to throw an exception if one of these two preconditions is not true, one or both. So we can copy files using the file system copy file function that I've never used before. So we have two paths, the original and duplicate. Here is an example of using the copy. We're going to copy stats.csv to stats.csv in a different directory. Notice we're taking the stats.csv from data and putting it in the backup directory. And we use the copy file. If the file system exists at the duplicate, if it does not exist, then we can copy to it. And this we're going to do only if it exists in the original. This is to avoid that throw. I bet copy file throws something, throws an error, which I haven't talked to you about. We have try catches and throws. So let's go find out. What was this thing called? It wasn't exists. File system, define the header file system. Here's the header. Recursive directory iterator. Copy options. No. Functions. Copy file. Here we go. From and to. Exceptions. Any overload not marked no except may throw a standard bad alloc if memory allocation fails. Throws a standard file system error if the from or the to don't work. So it's going to throw a file system error just defined in the file system. So it throws an exception if the files don't exist. Generally, if an exception is not caught with a try catch statement, the program will crash. Will keep throwing up until the operating system catches it and reports it as a crash. So it's going to throw an error. You can use the remove function to delete an existing file or an empty directory. So I can remove a directory that's empty. I can remove a file. The file directory structure is returns false if it doesn't work, true if it works, which is very nice. Specified path refers to a non-empty directory. An exception will be thrown instead of giving you a false. That's not very nice. Suppose if it's not there to delete, it returns false. And if it's full and you can't delete it, like it's there to delete but you can't, it's going to throw an error. Deleting after directory, a file system remove target path, and then it's deleted, otherwise error deleting. This will not do a throw, so a throw will crash this. So we try to do the remove on the if line, and we're trying to remove a directory that has stuff in it. It will throw an error. They're not even testing for the error here. Rename file systems. So you all have done this, right? You've gone through the Finder or the File Explorer, and you've renamed things. You can do that with your code, with all these things. There's this rename function. I'm guessing it's original and destination. So just change the name. Rename a file or directory. Make sure the file exists. Make sure the destination file does not exist. Rename. Otherwise, tell the user they goofed up. When using rename function to rename a file, if the source path is an existing file and destination path is non-existent, then the source path will be renamed to the destination. Source path is an existing file and destination path is also an existing file. The destination path will be deleted and source path will be given a new name. My guess is if destination path is a directory that contains goodies, it will throw an error. The rename function may be used to move a file directory. Source path is existing file directory and destination path specifies a non-existent file directory that is in a different location than source path. The source path will be moved to the location that basically renames the path. So it doesn't say what happens if you're trying to delete a directory that contains files. Huh. Here's directory stuff. Source path is existing directory, destination path does not exist, then it's just renamed. Source path exists directory, destination path is also an existing directory, results is system dependent. So they haven't defined what happens here. On some systems, an exception will occur. On other systems, destination path will be deleted, and then source path will be given the new name specified destination path. Rename function can be used to move a directory, and so on. So I do not know what happens if you're moving an old directory to a current directory that contains files. I would hope it will tell you you can't do that, but it may just overwrite that file. And then all the files in there would be gone. That would be unfortunate. Getting and sending the path of the current working directory. So we can change where the current working directory is by getting and sending the path, current path, and working path. I bet that is an environmental variable, current working directory. And so on. See what else we have. Create directories, can make new directories. Delete a non-empty directory. We have to remove, they have a remove all function. If you go to directory and do remove all, it removes all the files and directories that were deleted as an integer. Now I hope that the directory, let's say I have a directory of directories. I would call remove all in this directory of directories. Does it remove only empty directories in that directory? Or do we have to do remove all on those filled directories in order to remove them with a remove all? In other words, it's a recursive remove file or remove directory. That I don't know. Does it tell us? Delete a non-empty directory. We do remove all first, and then we remove the directory, right? So that's interesting what happened. Okay, I'm getting tired of these things. Getting the contents of a directory. We have a directory iterator and a recursive directory iterator. So we have two. The directory iterator will just show you what's in the directory you ask for. And the directory recursive directory iterator, if it finds a folder, will go into the folder and continuing the recursive directory iterator. So we can use this current directory iterator to iterate over it. So here's the format. For constant auto ampersand entry, colon, in the file system recursive directory iterator of current working directory. So they get the current working directory, and they are going through it with this auto.entry. So if it's a directory, it's a directory. If it's a path, it's a path. Get the path object for the current item and print it as a string. So that will show all the files and directories in a directory recursively. So it'll go into them. Here's an example of the output. Assignments is there, exams is there, exams is a folder. In exams is exam 1, exam 2, and exam 3. Labs is a folder, lab 1, lab 2, and lab 3. And schedule is a file. And we'll keep going. So if we see that here, we're in Blake. And if there's a folder in Blake, it goes into the folder. That folder contains more folders that go in those as well. So go as deep as you need to go and show you exactly what's there. It can be a humongous output. See, we have path, we saw that. Exists, we saw that. Is regular file, we did not see that. Is directory, we did not see that, so we can tell the difference between the two things. Is link, symlink, symbolic link. So we can link, you guys, how many of you do not know what a link is? You've heard link in directories. Y'all know? You don't know. Okay, so if I make a folder, and I can show you this in the Google Files. So here I go, lecture slides. And maybe I want to share something in different locations. So in lecture slides, I have this sample flow chart. Maybe I want to put this somewhere else. So maybe we want that in our lecture videos as well, the sample flow chart. Now I could make a copy of it and stick it here, but I could make a link. So I go to the lecture files, or sorry, students, and go back to our, those lecture slides. Was that where it was? Yes, sample flow chart. I can two-finger click on sample flow chart and do an organize add shortcut. Have you used shortcuts? You have. So that's what a shortcut. A link is a shortcut. And so a shortcut isn't the full file, but it says, if I click the shortcut, go and open the file at this location. So that's basically what a shortcut is. Those are also called symbolic links. And here we can see if this object in a location is itself a symbolic link and not the direct file. Other, if it's not one of the other things, and we can actually find the file size of these files. Root directory. We'll figure out if this is an absolute path. So if it is not an absolute path, it's going to return an empty path object. And if it is an absolute path, it returns the root directory. Root path probably does something similar. Relative path is probably the other way around. Relative to the root directory, what the? That one's weird. Parent path, file system, stem extensions. Do you guys have access to the slideshow? Or no? You guys do? Okay, good. So I'm basically skipping over a lot. Well, maybe you want to write the processor in C++ rather than Bash, although they're very similar. Bash is probably your better bet if you're constant with Unix. There are Bash interpreters for DOS, and you can write it in DOS. DOS has some similar commands to Bash. Yeah, generally, the more experienced users do that. This will allow you to do the similar thing in the function or the program itself. Function called chaining. Well, then bashes work better, don't they? They're still very tiny. For all of Bash? I don't know. But it does have size for C++? That seems counterintuitive. Use your Bash. So I missed that lesson. Yeah. But again, I don't really see a need to use this unless you have some kind of app that you're having users use that don't know Bash. And then you have them move directories around or something. Maybe that's it. But I suppose you could have that app just dump out a bash, run the bash, and grab the input back in. Here, you're doing that in the program itself. So maybe you have a GUI in C++ that allows you to do file operations. Okay, true. You can, I guess, delete everything off the root. That would be fun. Just leave the root there. And it should work because everything's loaded, right? Yep. Function called chaining. Let's see what we got here. So we have a current path dot file name dot string. So you can change the different functions in the file. We've seen this before, right? So path returns a path object. The path object has a file name, which is itself a string, and sorry, file name. I guess it's a file, and then we have a string on the end of it that will print it out as a string, and so on. Alrighty, so that is the file system. Again, I have not used the file system, so much of this I did not go over. And if you want to play with this, you probably need access to these slides. I think you do have access to these slides.